All right, so as you saw on the board, when you came into the room today, you need a calculator. You need your notes packet. We're going to kind of hop around a little bit in your notes packet. Finish the problems that we haven't quite done yet, or some of them, finish them up tomorrow and then Thursday, and then your test is going to be on Tuesday. That's a week from today. Okay? So it's after a long weekend. We don't have class after Thursday before your test. Okay? So, but your test still will be on the 11th because you're going to need 4 mods to do the test.
Oh.
It is a longer test. Okay? Well, because in the past we've made it 2 parts, but now that we've got the 4 mods, or it's going to be on a 4 mod day, we're going to make it just 1 part. So, yeah. Okay. You're going to get a homework, and another homework, I should say, today after you do the formative, and that homework will also be due the day of the test, because we didn't want to have you have to do on Thursday and then not be able to get it back to you before the test. So it'll be due on Tuesday. Okay? All right, so I got no clue where this one is in your packet. It should be one of the word problems. Navigation, it's somewhere in the middle. It's at the top of one of the pages. Okay? So a plane is flying with a bearing of 300 degrees and a velocity of 500 miles per hour. Because of the wind, the plane has a resultant velocity of 525 miles an hour and is bearing 305 degrees. We want to find the velocity and the bearing of the wind. Okay? So we've got to decipher what we all have in this particular problem. Okay? So the first sentence, a plane is flying with a bearing of 300 degrees and a velocity of 500 miles per hour. If I go back to our A plus W equals G equation, that first sentence, is that A, W, or G? It's A. Okay? So that's A. So let's figure out vector A first. Let's start by figuring out what the trig angle is of it. Okay, so our plane is going to be A. So 300 degrees would be up in here. So that would come all the way around here for 300. What would the trig angle be with that one? Trig angle with a bearing of 300. 150, do we agree with 150? Yeah? Okay. So our trig angle is 150 degrees. So what would the actual vector be then for vector A? I need help from an in general box a few pages prior to. You mean what? Nope. What do you got, Chris? Actual, like what you just said. 500 times the cosine of 150 degrees. Comma. 500 sine of 150 degrees. remember that a vector is the magnitude times the cosine of the direction angle, comma, the magnitude times the sine of the direction angle. Okay? So if I am figuring that out, 150 is on my unit circle. So cosine at 150 is negative root 3 over 2. So then that's going to be negative 250 square roots of 3. Sine at 150 is positive 1/2. So that's going to be comma 250. Agree?
Yes.
Okay. So that is my A vector. Found it, done, did it. Okay? What is the second sentence? Which one is that going to be? W or G? G. That one is going to be G. So let's figure out this. So now this is ground speed. It's got a bearing of 305 degrees, which is up here. What is its trig angle? What do you got at? 145. Do we agree with 145? Yeah. I'll explain it. Okay. So if this is 305 degrees, that means that this angle up here is 55 degrees. Agree? Because it's 360 all the way around. Right? So the trig then would start from out to the right. So it would be 90 plus 55 is 145. Okay? So my vector G then is going to be 525 cosine of 145, comma, 525 sine of 145. Which gives me vector G as, I got negative 430 and 301. Agree with those two numbers. Okay. Now, we need to find, let me just go back up. We need to find the velocity and the bearing of the wind. So we need to find the wind. How am I going to solve that vector equation for W? Huh? We could minus A from both sides. Yep. So the wind vector is going to be the ground vector minus the aircraft's vector. So my wind vector is going to be the ground vector, negative 430.065, minus negative 250 square roots of 3, comma, 301.128 minus 250. Now, when I did this problem about half an hour ago, I stored those values into my calculator because my calculator, I have a TI, and it has a storage component. Not everyone has that. Okay, so I see a lot of you guys using just the handheld scientific calculators, and that's great. If that's the case, you don't want to round, or you want as many decimal points as you feel comfortable with. I would say here at least 3 decimal points until the very end. Okay? You don't want to round until the very end. You want as many decimal points as possible. So that being said then, you should get a vector W that in component form is 2.95788, comma, 51.1276. My calculator has 6 digits is what it rounds to. Okay? That's the vector. What do we need out of that? Velocity and bearing. How am I going to find the velocity and the bearing of that vector? What do you got? What's that one going to give me? That'll give me the bearing. So you want to do bearing first, or you want to do velocity first? Velocity first. Typically what we do, which is what? So the magnitude of the wind is going to be the square root of, you can just say those squared. And then it's an A or an S word. Both of them are 3 letters. Add or sum, right? So the sum of those 2 squared, or those 2 squared added together. Okay? And so I get a velocity of the wind is 51.2131 miles per hour. Agree?
Yes.
Okay, that's a good thing. Then, Aster, back to you now. What did you say we need to do to find the direction? Inverse tangent of? Y over X. 1.1276 over 2.9578. And that gives me a angle of, I get 86.689 degrees. But what? I need that, that's my, well, first off, what quadrant is vector W in? It's in quadrant number 1. So my reference angle, so this is in quadrant number 1, where this angle here is my reference angle. Yes? So my bearing angle would be 90 minus that, right? So the wind is bearing 3.31 degrees at a speed of 51.21 miles per hour. Agree? Question? Find this one. A plane wants to maintain a ground speed. Is it the next one down?
Yes.
ground speed of 425 miles per hour, bearing 330. If the wind is blowing from a bearing of 145, is yours still a bearing blowing from 145?
Yep.
Okay, that's good. At 25 miles an hour, find the airspeed and the direction of the plane. Okay? So first sentence, is that A, W, or G? That's G. Okay? So if we've got G here, 330 would be up here. What is that trig angle? 120? Okay, I like that one. Second sentence. A or W? It's W. Now, here's the tweak on this one. It says if the wind is blowing from a bearing of that. So where is 145 degrees in terms of bearings? Which quadrant? It's in quadrant 4. Down here, right? So this would be 145 degrees, correct? But it's not blowing that way, right? It's blowing from that way, which means it's actually blowing that way. All because of this one word right there.
Can you explain why that word makes it that way?
Because it's blowing from that bearing. It's not blowing to that bearing. It's blowing from that bearing and going the complete opposite direction.
Okay, so when it says from, it's the opposite.
It's 180 degrees, yeah. So what is the actual trig angle here? What's this angle down here? What's that reference angle? 45? 55, right? That means that this angle right here is its vertical pair. That angle right there is 55. So the trig angle would be 125. Because it goes from here to there. Is the trig angle. Okay. So this is going to be G, and G is going to be 425 cosine 120. Oops, I put 455. Sine of 120. This one's going to be one is that. We have G, we have W, we obviously need to find A. So A is going to be G minus W. So blue minus green. Anybody? What do we get for the component form of vector A? Do we agree with those? Again, that was negative 198.161 or 1606 and 347.582. What do we need to find based off of that vector? So the airspeed is the magnitude or velocity, magnitude either way, and the direction, right? There. Okay, go for it. Find me magnitude and direction of that vector. I get that the pilot needs to set the bearing at 330.302 degrees at a speed of 400.101 miles per hour. Should be somewhere in your packet. I copied it right out of it. Yep. Additional examples number 1. Yep. Try that one. we'll let you guys do it, and then I'm gonna put up the answer. Okay? Go for it. So when it's all said and done, I get a ground speed of 338.654 miles per hour, and I get a bearing of south 23.93 degrees west.
I have a question.
I got an answer.
Do you want us to write it like that?
Yep.
Okay.
You know why?
So when it's in the question written like that,
Yep.
you want us to write it out.
Yep. That's exactly why. Questions on it? Yes, ma'am. My 23.93? Did you get the 66.0726 angle? Okay? So that's my reference angle here. Okay? Alright? So then this other angle is 90 minus that one. So 90 minus 66.0726 is 23.93, blah, 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 I rounded it. We don't need a lot of decimal points in there. To find the in the quadrant, yeah. Mm-hmm. Yeah. Because this angle here comes off this, in the actual answer, comes off of the vertical. Your reference angle comes off the horizontal. So yeah, so it's always going to be subtracted from 90 if you're in this form. If we weren't in this form, then we would have taken 270 minus the reference angle and gotten the bearing. Yep. Yep. Good? Take it for a minute.